Here we go.
Thank you. Good morning, everyone. My name is Katsuyasu Toyama of JPNAP, and today I would like to talk about an availability model of exchange point and the JPNAP case studies. Unfortunately, on the web pages, the title is only an described availability model. So maybe it is very hard for you to imagine what kind of talk I would like to do. But today, I would like to talk about availability of the exchange point. Okay? And first, I would like to briefly introduce what the JPNAP is. Okay? The JPNAP is one of the largest exchange points in Japan, and which is provided since 2001. Now, currently, 3 exchange points in Japan we have. The one is the JPNAP Tokyo 1, and JPNAP Tokyo 2, and JPNAP Osaka. And these 3 exchange points are not interconnected among them. So I mean that they are independent systems. And Tokyo and Osaka are approximately 400 miles away. So if there is a big earthquake in the Tokyo area, the providers can back up their traffic to the Osaka area. Okay? And also we built on one more site in Tokyo, the Tokyo 2. The Tokyo 1 and Tokyo 2 are 10 miles away. But then, as you know, the internet traffic in Japan is concentrated in the Tokyo area. So we have to hedge the risk, such as the terror or power failure. So we built another site in the Tokyo area, the Tokyo 2. Okay? And the JPNAP carries a lot of traffic. Currently at the peak, 146 gig. And this is the 4th largest all over the world. The top 3 is the Amos IX and DECIX and Lynx. Those are the 3 big guys. And the next is JPNAP. Okay? So let's go on to the availability model of the exchange point. So why availability? Because these days, as you know, the internet becomes infrastructure of our society. So these days, the people and the application service provider or content provider requires a very high level availability, stability, or reliability. So availability is important for also an exchange point. Okay? So first, I would like to propose the very simple but strict model of the availability about an exchange point. Okay? This configuration, the abstract configuration, is the typical one. So there is an exchange point network which consists of multiple Ethernet switches or some kind of switches and linked together. So this makes the switching cloud. And ISPs connect their routers to this switching cloud. So this connection is an exchange point switches and the routers connection. Okay? So there is a demarcation point between them, the exchange point network and ISP's routers. So between this, it's responsible for our exchange point. So from this perspective, I would like to define the simple availability model. Okay? So the definition is the exchange point is available if no packet loss and no link failure in the switching cloud, and all ports for the customers are up and running. I like to define this. The normal case isn't available. Okay, so let's imagine not available cases. And the typical one is the packet loss or link down in a switching cloud. Of course, exchange point should be regarded as a big pipe for all the customers with enough capacity and bandwidth. So in this cloud, we have to, the exchange point provider have to maintain no packet loss and no link failure. Such kind of state is very important. So, okay. So if there is some packet loss or link down in here, so this network defined as not available. Okay. And sometimes the ISPs push their traffic into a switching cloud, but then sometimes they put too many packets to this line. And this one is responsible for a provider side. So this one is not defined as an unavailable. Okay, only at this side. Okay. And the second part is one port is down for a customer. This case is defined as an unavailable. If in case that the port for ISP B is down, that is not affected to a peer with others. But the potentially ISP B will have a BGP connection in the future or some kind of things. So only one port is down is also not unavailable. So the exchange point provider should maintain all the port is up and running. So, okay, so this is a very, I think that the simple but a strict model. So exchange point provider should maintain exchange point network itself is in no packet loss or no link failure, and also all the ports are up and running. And the next, I would like to talk about the JPNAP technology to improve availability. Okay. And the first step is using the network itself are redundant. Okay. So not only the switching network, but we add the redundant network. And also we provide the main port and backup port to our customers, all the customers. Okay. And inside a network, we are using some kind of redundant protocols to maintain the this network is available. Okay. And the next technology is an optical switch for customer port. Okay. Well, this optical switch changes from main port to backup port instantaneously. Instantaneously means tenths of milliseconds. This optical switch always watching the light from the ether switch to the customer end. And if the light is going down, the optical switch soon change the port to the backup side. And it is done in a tenth of milliseconds. And this means the most routers do not sense link down, and therefore the BGP sessions are not down. This feature is very important for the providers, I think. Because if the link down is sensed and the BGP session is down, the router starts to recalculate the best route, best path, and best route again. And if after that they recover this one, yeah, the routers again recovers to that this path is the best. So if the BGP session not down, so if the BGP session is not down, such an recalculation of the route will not occur. So the providers use this exchange point network is very stably. Okay? And we also use this optical switch when we are doing the maintenance work. So when we would like to maintenance work on the switch, we can easily we can easily change to the backup port, and the switch, we can easily maintain the switch during the traffic is backing up. Okay. After the maintenance, we will recover to the main path. Okay. So I would like to use the JPNAP's real data, and this technology is how effective this technology is. Okay. This list is our troubles and maintenance works at the JPNAP Tokyo 1 from June 2007 to May 2008. So exactly 1 year. Okay. So there are 18 events during this year. And the green one shows that the maintenance work. Okay. And yellow one shows a switch network trouble. And red one is a human error. We sometimes made a misoperation. Yeah. So during this year, we have 18 events of troubles and maintenance and misoperations. Okay. So next, I would like to use this data and how effective those technology is to improve the availability. Okay. So, first, focusing on the maintenance work. Usually, the maintenance work is done for this time period. Okay. And if we did not have a redundant network, IX service would not be available during the maintenance window. So, yeah, assuming this, and I calculated the total hour of the maintenance work was 26 hours and 34 minutes. So if we did not have a redundant network, these times are equal to the downtime. Okay. But then we have a redundant network. So redundant network and main and backup port for all the customers. So when we do a maintenance, the customer's connection to a main port to remove and insert the backup switches. It may take 15 seconds at least. So first main to backup, and after the maintenance backup to main, it will take 30 seconds. I estimated it would be 30 seconds. So during this maintenance work, the impact is approximately there's 10 customers, and this time in 20 customers. So for each customers are 30 seconds. So we have to, the network would be unavailable during the 5 minutes. In this case, 10 minutes. Okay, so if the switching network was redundant, but there is no optical switches, the downtime would be 62 minutes and 30 seconds. Okay? But as I told, we had a redundant network, also optical switch for customers, for ISPs. So the downtime, optical switches changes the main port to backup port in a tenth of millisecond. So for this time, approximately at most 1 second is in downtime. And this one is approximately 2 seconds. So summarize some of these times, approximately 15 seconds is the real downtime. So how much the availability differs? Okay. Focusing on this maintenance work, the downtime, the first case, if we had not the redundant network nor optical network, the downtime is 26 hours approximately. And downtime, the ratio is in 0.30%. From the availability side, 99.7%. But if we had a redundant network, at the time, in the case, the 16 minutes would be the downtime. But currently, the JPNAP using the redundant network, also optical switches, so the downtime is approximately 15 seconds per year. So the downtime is 0.000047, and availability would be this one. So this data shows that the redundant network and the optical switches are very effective to increase the availability. Okay? And as I told, the optical switches are always watching the light from the Ethernet switches. Okay? So next, I would like to focusing on the human error. This case, we mistakenly put the power off of some transmission device between here. And fortunately, the optical switches detect the failure and instantaneously change to the backup port. So this trouble does not affect our customers' network. But then if we take the bad scenario, probably it was about 30 seconds to notice the mistake and recover it. In this case, the operator is just in front of the transmission device, so they soon noticed the failure, the mistake. So it may recover approximately 30 seconds. Okay? But then, actually, slowly, as I told, the optical switch changed to the backup port, so there will be approximately 1 second, much more less than tenths of milliseconds is affected to the customers. Okay? So the totally availability of the JPNAP Tokyo 1 during this year was approximately 99.976%. And downtime was in 2 hours and 7 minutes. And this seems to be too long. Yeah, and this is according to the definition of my availability model, which is very simple but strict. And this case is it took a long time because this failure is it was very difficult to determine that customer side is wrong or the JPNAP, our side is wrong. And also we had to negotiate with our customers to repair, to take some steps to recover the failure. So that is a problem to be solved next time. But then please take a look at these impact side. From the impact side, the backbone network of our switches, the failure is approximately 64 seconds per year. So almost all our customers can be used our network all the time, and it would the availability was 99.9998%. So quite long, I think. So to summarize, I presented a very strict but very simple but strict availability model exchange point. And using the model, I calculated the JPNAP availability. And availability can be significantly improved by redundant switch network and optical switches. Thank you very much.